Hello, my name is Todd Dust, and I am a PSoC Applications Engineer at Cypress Semiconductor. Today I am going to give a quick overview of dynamic reconfiguration in PSoC 1 and how to configure PSoC Designer to accomplish dynamic reconfiguration. All of the information found in this video can be found in Application Note AN2104 PSoC 1 Dynamic Reconfiguration with PSoC Designer. So what is dynamic reconfiguration? Dynamic reconfiguration is the ability to change the functionality of analog and digital resources on the fly. PSoC hardware is made of digital and analog blocks. These blocks are configured via registers. See here a screenshot of the analog and digital blocks as would be seen in PSoC Designer. These digital and analog blocks are the building blocks for Cypress user modules, such as PWMs, timers, counters, PGAs, ADCs, filters, and much more. Because these blocks are register configurable, they can be easily changed from one function, such as a PWM, to another, such as a UART, during runtime. This allows designs to implement multiple functions in the same hardware resource. This process is known as dynamic reconfiguration. PSoC Designer, Cypress's free integrated development environment, provides an easy and automatic method to accomplish dynamic reconfiguration. Application Note AN2104 describes in detail how to configure a project for dynamic reconfiguration. As said before, dynamic reconfiguration allows us to share hardware resources in the PSoC. This allows us to squeeze the maximum performance out of the device. Say for example, you created a design and you only had one digital block left, but still needed to implement 4 more digital functions. If these digital functions occur at different times, this can easily be accomplished by dynamic reconfiguration. For example, say you need to drive a buzzer with a PWM. You will most likely only need to drive the buzzer for a short amount of time and won't need it always on. Or say you need to read data from an SPI slave. Again, you probably don't need to read the data all the time, so the time that the data is not being read, the block can be reconfigured to accomplish another task other than an SPI master. Another task could be having it configured as a counter to count specific events. Again, this counter may not be needed all the time, so the block can be reconfigured for another function, such as a UART transmitter to transmit the results of a count to another device or PC. The key to dynamic reconfiguration is time slicing. The different functions have to occur at different times in order to use dynamic reconfiguration. Dynamic reconfiguration will not work for designs where the separate functionality is needed all of the time. So what are some real-world examples of where dynamic reconfiguration can be used? First, we will take a look at an electric shaver. A typical electric shaver may need battery charging and motor driving functionality. It may be possible to use a smaller PSoC with limited resources to cut costs for this application. A more limited device would only have the resources to do either battery charging or motor driving, but not both. Dynamic reconfiguration allows the PSoC to perform both operations. Dynamic reconfiguration does this by time multiplexing the resources inside the PSoC. Since motor driving and battery charging do not occur at the same time, it is possible for them to share internal PSoC resources. Another example is that of a vending machine. During normal operating hours, the device is configured to participate in normal vending operations such as monitoring money collection, calculating change, controlling product dispensing, etc. At predetermined intervals, the device will reconfigure itself to participate in inventory activities, such as calculating totals of products sold, determining need for additional products, and participating in modem operations to communicate with a central resource. Both of these functions can independently fit inside the PSoC, but they cannot both fit at the same time. Since the operations occur at different times, dynamic reconfiguration can be used. A final example is that of capacitive touch or capsense design. Most PSoC devices that have capsense functionality have limited digital blocks, typically 4. The capsense user modules consume 3 of those digital blocks. Often more functionality is required than will fit in that one block. Dynamic reconfiguration can be used to squeeze the maximum performance out of the digital blocks to achieve all the desired functionality. Here are some examples of different configurations that can be dynamically loaded into a device to accomplish different functionality. This is an example of the capsense project mentioned earlier. In the first configuration, we have a CSD user module placed to scan for button presses. We must ask ourselves, do we need to be scanning for button presses all the time? If the answer is no, then we can safely load and unload this capsense user module. In the second configuration, an ADC is used to read temperature. Again, do we need to constantly be reading the temperature? The answer is most likely no, so we can safely load and unload the ADC, freeing up the resources for other functions. Next, we send data out via UART. Again, we don't always need to be sending data over UART, so this block can be loaded and unloaded to be used for another function. The same applies to the next configuration. We are reading responses over UART. Again, if we understand the system requirements, we can determine when we need to be listening on the UART channel and when we don't need to listen. This allows us the ability to free up this block for other tasks. Dynamic reconfiguration is a powerful tool that allows you to dynamically reuse resources in the PSoC device. The key to dynamic reconfiguration is understanding that you don't need all your hardware functions active 100% of the time. Again, this allows you to get the maximum use out of the PSoC. Much more detail on this can be found in the associated application note, AN2104. So how do we configure a project for dynamic reconfiguration? First, let's open up PSoC Designer. It is actually quite easy to configure your project for dynamic reconfiguration. If you look in the Workspace Explorer, you will notice there is a folder called Loadable Configurations. In this folder are all the different configurations for your project. Since this is a blank project, there is only one configuration, the base configuration. To add configurations, right-click on the Loadable Configurations folder and select New Loadable Configuration. A new folder should appear titled Config1. You can rename this folder by right-clicking on it and selecting Rename. Then you can come over here and you can give it a new name. You can also delete files by right-clicking as well. Now that you have your new configuration or overlays, you can easily add user modules to your project. Before we move on, there are some important terms to cover. Base configuration. This is the first configuration that is loaded after device reset. This configuration is always loaded and should never be unloaded. Overlays. These are the configurations that are loaded on top of the base configuration. Now that you have a basic understanding of dynamic reconfiguration, what it is, why it is used, and how to configure PSoC Designer for dynamic reconfiguration, let's take a look at the design flow when creating a project with dynamic reconfiguration. The first step is to determine the required functionality of the project. With this, determine which user modules will be used to accomplish this functionality. Next, determine which user modules need to be enabled at all times. Place these user modules in the base configuration. Next, determine which functions can be implemented at different times. Place the UMs for these functions in separate overlays. Finally, ensure that all global resources and pin settings between the base and overlays are as identical as possible. This will help reduce code size and reconfiguration time. Some settings will have to be different, but try and keep the differences as minimal as possible. Once you have done this, the hardware portion of your design is complete. Again, for more detailed information, consult AN2104. Below is a list of all the dynamic reconfiguration application programming interface and an example flowchart of a dynamic reconfiguration design. The important thing to note is that before unloading a configuration, all of the associated user modules should be disabled and their associated interrupts should also be disabled. Directly after loading a configuration, the user module should be enabled, all pending interrupts should be cleared, and the user module's interrupts should be enabled. Doing this will ensure a smooth transition between overlays. Again, for more detailed information, consult AN2104. Last, let's look at some simple best practices. Number 1, place all user modules that are loaded all the time into the base configuration. This helps to avoid accidentally unloading one of these user modules. Number 2, along the same lines, keep I2C in the base configuration. If I2C is loaded or unloaded, it will cease to function properly. Number 3, ensure that your overlays do not conflict with each other or override each other. PSoC Designer has no way of checking to see if a block is free before loading an overlay, so you, the designer, need to ensure that the block is free before loading something into it via an overlay. Number 4, be aware of pins that are driven by digital blocks that are unloaded and loaded. For example, the TX pin of a UART. What state will it be in if there is no UART present to drive it? To ensure the state of the pin when the user module driving it is unloaded, use the digital output row lookup table to set the desired logic level. Number 5, keep global and pin settings the same between overlays. This will reduce the amount of code needed and reconfiguration execution time. It will also reduce undesired device behavior. For more information on dynamic reconfiguration, including a discussion of interrupts, time to load an overlay, dynamic reconfiguration files, and much more, consult application note AN2104 PSoC 1 Dynamic Reconfiguration with PSoC Designer. Also included with AN2104 is a working example project demonstrating how to accomplish dynamic reconfiguration. Thank you and have a good day.